BrahMos-NG, compact supersonic strike for jets, ships, and subs. A new generation of BrahMos aims to put supersonic punch on more platforms, more often. BrahMos-NG takes the core of India's flagship cruise missile, solid rocket booster to ramjet sustainers, sea-skimming endgame, and agile terminal maneuvers, and compresses it into a lighter, shorter package. The result is a weapon that fits under more fighter wings, slots into denser ship loadouts, and slides through submarine tubes, turning dispersed forces into a single, fast-hitting strike web. The design logic is compact-powered. Shrinking dimensions and mass without losing the ramjet's sustained supersonic cruise lets planners trade one heavy store for two lighter ones on a fighter, or add extra cells on board a frigate. For aircraft, that translates into multi-missile carriage on Su-30 MKI and pathway integration on naval and indigenous fighters, with lower drag and quicker acceleration after release. For ships, common canisters and tight VLS spacing increase ready-to-fire counts without stretching hull margins. For submarines, torpedo tube launch and plug-in vertical modules open choices between covert single shots and heavy salvos. Guidance and seekers carry forward the family traits with upgrades. An inertial GNSS mid-course spine keeps the missile on a low, efficient path. Two-way data links allow course corrections from the launching platform or another node, so targets that maneuver or change speed are still met at the right point in space. A modern active radar seeker with better side lobe control, smart clutter rejection, and home-on-jam logic sharpens terminal aim, while the mission computer picks sea-skimming or pop-up profiles based on target type and sea state. The lower radar cross-section that comes with a smaller airframe is a bonus in the last miles. Kinematics are about time and geometry. Supersonic cruise compresses defender reaction windows. Sea-skimming keeps the missile below many radar horizons until late. Programmed weaving and high-G terminal jinks stress fire control solutions. Against surface combatants, the playbook mixes bearings and heights. One missile stays low for a waterline strike as another executes a short pop-up to dive on the superstructure and sensors. Against land-sea interface targets, coastal batteries, radars, logistics piers, the missile can fly a terrain-hugging or coastal skim route, and then execute a steep terminal to hit small aim points with unitary warheads sized for the NG form factor. What NG changes most for air forces is sortie math. A fighter that once carried a single heavy anti-ship missile can now carry a pair while retaining fuel and air-to-air weapons, or mix one NG with standoff glide bombs for cost-effective layered strikes. Shorter missiles ease taxi and deck handling, reduce pylon stress, and allow faster turnaround. Multi-ship strikes become more practical. Two aircraft can loft 4 supersonic rounds from different vectors, queuing off a patrol aircraft or ship radar track, and then turn cold while the weapons race ahead. On the surface fleet, density is deterrence. More cells loaded with NG variants raise the number of simultaneous shots a frigate or destroyer can fire before reload, improving saturation potential against high-end targets. The same cells can hold land attack or anti-ship mission plans, giving a commander flexible packages without changing hardware. Coastal batteries using truck-mounted canisters add yet another axis: fast relocation, shoot and scoot doctrine, and the ability to complicate an adversary's approach lanes near straits and bases. Submarines get the quietest value. Tube-launched NG rounds allow a diesel-electric or AIP boat to hold surface groups at risk while remaining deep and slow, or to strike coastal nodes without exposing the hull near the surface. When vertical launch is available, staged salvos, 2 low, 1 pop-up, timed seconds apart, force defenders to split interceptors and sensors. For undersea forces, the smaller round means more weapons on board for the same patrol, extending pressure across a longer campaign. Networks turn NG into a system rather than a store. Maritime patrol aircraft, shipborne AESA radars, helicopters, and satellites feed tracks. The shooter, air, sea, or sub fires on a composite picture. Cooperative engagement allows a platform with poor line of sight to launch on another's queue, while mid-course updates refine the path until the seeker takes over. The payoff is confidence. A missile launched on incomplete data becomes a missile guided by a constantly improving picture. Counters exist and are priced in. Defenders deploy long-range surface-to-air missiles, hard-kill close-in weapons, and soft-kill decoys. NG answers with speed, low terminal altitude, bearing diversity, and seeker agility designed to resist seduction by chaff or corner reflectors. In mixed packages, drones or decoy missiles draw early intercepts. NG arrives moments later when channels are saturated and reaction time is gone. Sustainment and sovereignty finish the story. Common canisters, electronics, and test gear with the wider BrahMos family simplify logistics. Indigenous software and seeker work enable faster updates as tactics evolve, and production tuned for higher volumes lowers per-shot costs, making realistic training and credible magazine depth more achievable. The bottom line is a broader, faster reach. By putting supersonic precision into a smaller frame, BrahMos-NG lets India's fighters, ships, and submarines act together at higher tempo, from more directions, with less warning to an adversary. Exactly what a 21st century strike web demands. For deep dives on supersonic strike tactics, multi-platform integration, and India's next-gen missile roadmap, visit globalinfoveda.com.